Let's start off this video lesson with a recap of the characteristics of a high pressure cell. High pressure cells are also called anticyclones. On the cross section, you will notice that the air initially starts off high up into the atmosphere where it is cold and dry. It then sinks or subsides towards the Earth's surface. It is important to remember that when the air sinks, it warms up as it gets closer to the Earth's surface. This in actual fact evaporates any liquid water in the air and thus creates sunny and clear conditions. At the center of a high pressure cell, the air then diverges outwards. In the southern hemisphere, as it sinks, the air is going to rotate in an anti-clockwise direction away from the center of the high pressure cell. You are required to identify the location and name the specific high pressure cells over South Africa, and they are as follows. Over the Atlantic Ocean, we have what is called the South Atlantic high pressure. Over the Indian Ocean, we have the South Indian high pressure, and over the interior of South Africa, the Kalahari high pressure. Do ensure that you're able to name them specifically, because on occasion the examiner will require this from you. The South Atlantic high pressure is located over the Atlantic Ocean, where there is the presence of the cold Benguela current. When an air mass moves over a cold body of water, it takes on the characteristics of that body. Therefore, air coming off the Atlantic Ocean and air associated with the South Atlantic high pressure brings cold, dry conditions to the west coast of South Africa. The South Atlantic high pressure is characterized by diverging air which rotates in an anti-clockwise direction around the central lobe and approaches the coastline of South Africa from the southwest. It is important to remember that this Atlantic high pressure cell feeds cold and dry air from the southwest, and this is an important component for the formation of line thunderstorms over the interior of South Africa during summer. Both the South Indian high pressure and the South Atlantic high pressure move horizontally across the face of the earth in response to the positioning of the sun with the changing of the seasons. Both cells located off our oceans will move northwards during our southern hemisphere winter and move southwards during the southern hemisphere summer. The South Indian high pressure is located over the Indian Ocean, where there's the presence of a warm Gallus current. Air traveling over this current becomes warm and moist. This air associated with the South Indian high pressure that reaches the coastline of South Africa increases temperature and rainfall along the east coast. The South Atlantic high pressure feeds in warm, moist air from the northeast of the country, and again this warm moist air from the northeast is an important component for the development of line thunderstorms over South Africa. Finally, the Kalahari high pressure cell is located over the interior of South Africa. This Kalahari high pressure cell has an important influence on rainfall patterns over the interior of South Africa. The Kalahari high pressure cell, unlike the high pressure cells of our coastline, moves vertically with the changing of the season. At certain times it is closer to the Earth's surface, and at other times it is higher up into the atmosphere. During winter time, the high pressure is closest to the Earth's surface, and therefore it is present on the winter synoptic weather maps for South Africa, as these weather maps generally only show surface conditions. However, during summertime, intense heating of the Earth's surface pushes the Kalahari high pressure cell higher up into the atmosphere, and therefore the Kalahari high pressure is not present on our synoptic weather maps. It is important to remember that this cell does move vertically with the changing of the seasons, either closer to the Earth's surface or higher up into the atmosphere, and this movement has a significant impact on rainfall patterns over the interior of South Africa.